Welcome to clickmyproject.com. Our product title is Efficient 3D Bus Architectures for Inductive Coupling through Chip Interfaces. Let we see our process abstract. The wireless 3D network on chip with inductive coupling through chip interfaces provide a large degree of flexibility for customizing the number of arbitrary chips in the package after chips have been fabricated. To simplify the vertical communication interfaces, static time division multiplex access (TDMA) is used for vertical broadcast buses, while the arbitrary and customized topologies can be used for the interchip network. This paper process we have two techniques of the breakthrough the simple static TDMA based vertical buses, while maintaining the routing to reduce the waiting time for accuracy communication time slot. The routing selects best vertical bus based on the current time, taking advantages of the static TDMA process. The second technique is extend carrier sense multiple access with collision detections for vertical broadcast buses. We introduce the packet collision detections buses static reduce the waiting time for packing retransmissions caused by the collisions. Network simulation result we have provide the based for TDMA bus based 3D NOC process, and the process we can inductive and the semiconductor technologies allow integrated various chips vertically single package. This TDMA based vertical buses periodically grant to communication time slot for different set of the same times, which means the time slot assignment scheduling the phase shifting each vertical bus behaves given the destination point of the communication latency estimation, and then CSMA process vertical bus without waiting the bus allocating under the low afford workload the carry sense of the process, and then coupling the link of the process retransmission strategies to reduce the waiting time and packet transmission collision process. Now we can discuss about our process flow diagram. In our process we have given the source router input for 8-bit data, and then we have designed the mesh topology based NOC design, the 3D design, and then this process we have single router architecture we have designed it. The router architecture is used to store the input data and the main data bits using the clock signals. The router architecture is one type of the data storage and data control process. The router sections is used to maintain the signal energy level due to the long data transmission process. In our process, the design the forecast for router architecture and apply the mesh topology connections between the forecast for NOC designs. The forecast for NOC design to reduce the energy consumption level for inter and intra chips communication process. So we use weighted bit calculation for every router placement position in forecast for NOC designs, and then we have going to the neighboring router estimation process. In the process we have calculate the weighted calculation process, the pre-processing work for the data transfer process to analyze the all router positioning level and find the shortest path difference between the source and destination routers. So we check the low weighted level for the nearest neighbor router estimation process, and then we are calculating the weighting calculation for PS and CS and VCS. So the weighting calculation is mainly focused by the packet switching circuits switching for the virtual circuit switching. The switching conditions are considered the connection between the every router positions level. The weighted level is used to analyze the data selections control level of router architectures, and then we are going to the neighbor router estimations. The data transfer process analyzes the all router positions level and to find the shortest path between the source and destination router. The neighbor router estimation process the analyze the minimum routing weighted bits. The neighbor router estimation control is used to check the shortest path identification control, and then we go into calculate the distance calculations. The distance calculations to calculate the low distance route for shortest path identification. The minimum distance level is to identify the shortest route between the source and destinations. So we have going to our process mainly maintain the continuous and to reach the destination process on time, stop the destination calculation process, and then we go calculate the processing analysis report. Now we can see our process running procedure. We can implement our in our process 3D mesh topology for design and Linux 14.2. We have implement this process. This is our process. Now I'm going to simulate from process. So just we have given the simulation and the NOC process for going to simulate the behavioral model. The iSim simulator is automatically open. Now we can do the process for clock and input processing from iSim process. Now we are going to right click the process and we give the force clock. We can give the leading edge value for 0 and the trailing edge value for 1. The period for 1000 nanosecond in our process. Apply and OK. After we are going to enable the process for 0 and then giving the input data. We have input data for undefined data, so we can give us 8-bit data for 01010101. Process completed. I'm going to the running the process. This process is run and then get the enable function for 1. Go ahead to the enable function 1 after running the process. What are the we give the input for the 01010101 process input, which port we define that. So the output for 01, the destination is output, which port is defined that process defined. This is a path considering this process path 1 2 3 and 10 1 and 30. So this is bus connected to the destination point. So we have designed the process for 3D type of NOC mesh topologies process. Is giving the input and get the output the where the path from gate path. After we go into the implementation process for the now we can go into the implementation result for technology development and synthesis report, get the values. So running the synthesis report running after implement results, the both are running after we can give the synthesis report and the implementation result and the RTL schematic diagram result is will be there. The last we have VHDL synthesis report. We have latches and latches comparator time. So we are using the 1 bit and 2 to 1 multipliers. We are using the 48 latches for flip-flop and 8 bit for 2 to 1 multipliers for 5. So we can optimize the each and every processing implementations result. Thank you for viewing our website.